for number 1, you can see that it asks us that if we invest $200 in the stock market in 2005, how much money would your $200 be worth in year 2022 if each year it grew at a rate of 10%? So what we're going to do is we're going to use this equation to help us to solve. So you can see here that I set up my equation like this, like so. This one you can ignore. So what's going to happen is that my initial amount is 200, so I'm going to put that 200 right here. Remember that P represents the initial amount that I have. So P represents the initial amount, or the amount I'm putting in initially. So in this case, it's going to be 1 plus R because it's increasing every year. So it's going to be plus, and it's increasing at a rate of 10%, so it's going to be 0.1%. Okay, so 10% is represented by 0.1 because it's growing at a rate of 10%. And the number of years, how we calculate that is that we know that they're asking us in 2022, but it started in 2005, so we can just go ahead and subtract the years from each other. You could have just done 22 minus 5 because the year 2022 minus the year 2005. And A represents our answer. A represents the future value or the future amount. So we can just write A. We don't know what it is yet. That's what we're solving for in this case. This looks like a very difficult problem, but I could rationalize this to put in my calculator, or you could just write it as is and then just put it all in your calculator if you don't want to mess up. So what I did is I just added 1 plus 0.1 in the parentheses, and then I just subtracted the years. But you can see that I will still get the same answer. Oh, this is not my calculator. So you can see here that this would be 200. So if I were to put this on my calculator, I could actually put it with the bigger one. So I could do 200 times 1 plus 0.1 to the 2022 minus 2005. And you can see that my answer is 1,000 is equal to 1,010 and 89. So basically what happened is that if I invested in, let's say, this stock market in the year 2005 with $200,000, and it compounded annually with an interest of 10%. In this case, I said $200, but let's just say we raise that amount to $200,000. In this year, you would have $1 million. So by investing $200,000 at a stock that gives you an interest rate that compounds annually at a rate of 10%, by doing nothing, by just leaving it in there, you actually would receive $1 million. Pretty cool. So the power of stocks, or the power of compound interest, is that you're actually gaining money every single year by investing in something that will give you a return of 10%. So every year as you leave your money there, it's actually not that you're gaining just 10% of 200,000, you're gaining 10% of whatever you're leaving or putting back into that stock. Just as a reminder that stocks can be volatile. You could lose everything here, so you might have had some losses and you might get something more like 800,000. But in this case, this would be the most optimal amount. If you gain the same amount every single year, then this would be very beneficial. Okay. So let's do another problem. We're going to just kind of walk through each of these problems. For number 2, what I would like you to do for today's worksheet is that you're going to actually use the depreciation amount of 2 years. For yesterday's homework, I wanted you to use the depreciation amount of 1 year. If you ever become an accountant or you ever invest in real estate, just know that you can deduct the building from your taxes. That's something you guys will, I guess, figure out later since you guys are only in high school. But if you want, you can get your real estate license at age 18, so there's really nothing holding you back. Okay, so what does it mean about depreciation? So there's this idea that if you own a building, you are going to get taxed on the whole value of the building. So meaning, if you own a $1 million building, the government wants to tax you on it because, in a sense, it is part of your net worth. And so the government believes it is okay to tax you on that amount. What's interesting is that they say, well, okay, since you own that building, we know that there are maintenance costs involved. We know that the building will depreciate, meaning it will lower in value. So we will cut you some slack and we will give you this depreciation formula where we will tax you on the depreciated amount of your building. So every year, they can actually tax you on less and less on the building that you owe. Okay? This is something called a tax shelter here. If none of that made sense, that's totally fine. You can see that we're going to set it up exactly the same way. It's going to be that A, our future value, is determined by our present value times 1. And in this case, since we're losing value, it would be 1 minus the interest rate of 0.03636. And in this case, because it is only 1 year, we're just going to put 1 year in the top. Okay. Oh, yeah. So this is, so our initial value is 1.2 million. So I'm going to write this in regards to millions. This is 100%. So again, it's just 100% minus whatever the percentage is, 0.03636. And this is the depreciation after 1 year. If the year is more than 1 year, you can go ahead and put the different year in the top right. You can see that this is how you would write it. Again, A is your future value or what it's going to become. So again, you could just put this in your calculator. You could just go 1.2 parentheses 1 minus 0.03636 parentheses to the first power. And you can see here your value would be 1.156. And we can even write 368. So what is the significance of this, right? What is the significance of this? Well, let's just say that let's actually Google tax rate on buildings. So let's just say you get taxed on owning a building at 1%. So for California, the national average is 1%. So what that means is that at 1.2 millions, you get taxed at 0.017, which means, let me change this. Which means that every year you're going to pay $20,000 in taxes on that building if it was the original amount. So if you let's just say you own a house and you have to pay an annual amount of taxes, you're actually going to pay $20,000 in taxes on that building that's worth $1 million, $1.2 million. But by depreciation, instead, 1.15638 times 0.017, you're going to pay only $19,600. So you can see that the difference here is that instead of paying $20,000, you're paying actually $350 less in taxes. And you can see that as the building value goes up and up, you're going to save more and more money. And so what's interesting is that actually as the years go along, you'll pay less and less taxes on that building because of depreciation. So if you ever buy a building in the future, whether it's a home, income, so if you rent out homes to other people, if your parents rent out homes to other people, just ask them, are they, taking that off their taxes? Because they definitely can. If they aren't, they got to get a new accountant because they should have been. Okay. So these are interesting real-life applications of how you calculate depreciation in value, and also, so it's actually good that your building depreciates so that you pay less in taxes. Very interesting concept. Okay, so on number 3, I also didn't give you enough information, which is my mistake. But for the future, I'm just going to show you that you would just do it at 10%. So I know I forgot to put the interest rate for both, but again, just go ahead and put it at 10%. So for number 3, it's asking us, what happens if I invest in something that compounds daily versus something that compounds 4 times a year, which is also known as quarterly. If that sounds familiar, quarterly is just like in basketball games or in football games where it's divided into 4 different quarters. Actually, I don't know about football, but basketball is that way. So in this case, you would have y is equal to, so same thing, a is equal to p, 1 plus r over n, nt. So the only difference here is because that we are compounding, now we have to divide by how many times we're compounding, and then we're also going to raise it to the power of how much we're compounding. Okay, so in this case, if we put an initial amount of $1,000, our percentage is still the same, starting at 100%. We know that it's going to grow, so it's going to grow at a rate of 0.1 divided by, and since it's compounding every single day, there are 365 days in a year, and we're going to raise it to the 365 times, and it asks us 3 years, so it's going to be times 3. So again, the 365 represents how many times it compounds in a year. 3 represents the number of years. 0.1 represents the percentage it grows, so how much money are you earning every year? So in this case, 10%. 1 represents just your initial value, which is 1,000, and then we have 1,000. So if you just times your initial amount by 1, it just equals itself. Okay. So this means we're going to get our initial amount plus whatever amount. Okay, so at this point, if you're not sure what to do, you just put it in your calculator. I'm just going to type this crazy thing in there. And you can see here that you would have 1,349.80. You would have 1,349.80. And for your other one, just as a reminder that you're setting one up, this is the REIT. The other one is you're only compounding 4 times a year. Sorry, so let me write it as 1,000 and you can actually enter it in the same way. And we get a different answer of 134488 or 89. So what you can see here is that if I compound every single day, let's see, this is the stock. You can see that the one that compounds every single day is actually earning more money than the one that only compounded 4 times that year. The difference here is pretty minimal. It's about $5,000. But again, every little bit, if it has an advantage, this helps you to determine which one is a better investment, right? Which one's a better investment. You could invest in both and then see, so in this case you could add up together to see how much you earned in total. Okay, I'm going to go over the last one real quick. So this last one is different in the sense that it tells us the value of a truck and it asks us when will it depreciate to that amount. So in this case, we're going to have, again, our initial formula, A equals P1 plus or minus R to the T. In this case, it doesn't compound, so we just use this formula when it doesn't compound. So it's asking us, well, the amount is going to reach 5,000, so we already know our future amount. We have our present amount, and then we know that it's going to devalue or lose value, depreciate, so 1 minus R to the T years. They tell us it's going to decrease at a rate of 9.5%, so it's going to be 5,000 equals 28,000, 1 minus 0.095 to the T. So what you would do first is you would divide both sides by 28,000. You're trying to isolate T. And you get 5,000 divided by 28,000 equals 1 minus 0.095. And then you would take the ln of both sides. If this looks familiar, that's because it is. And then I would divide both sides by ln of 1 minus 0.095. And then I could just put this into my calculator. It looks super crazy, but again, this is what you would put in. So you do ln of 5,000 divided by 28,000 divided by ln of 1 minus 0.095. And you get T is equal to 17.25. So how we look at this answer is just that you know within 17 years that your car is going to depreciate from $28,000, the original amount, to $5,000. So what we've just solved for here is that based on a percentage decrease, we actually can find the future value of something, which is kind of cool. So we use this a lot when determining value of money. Just as an example, as I said before, your dollar today is worth less than it is yesterday. Or, yes, yeah. So your dollar today is worth less than it is yesterday. So each year it can depreciate 2%, so that just means $1 this year, or $1 last year is now worth 98 cents this year. That's what it means. So again, if you just keep your money in the bank, if you just keep your money under your bed, it's actually going to lose value. Okay? Something interesting to know. Okay, we're going to work on this for the next couple weeks, probably 2 weeks. So if this is really complex or it's really boring, I'm sorry, but you're just going to have to understand it. Okay?